Good evening, everyone. My name is Melissa Raspberry, and I have the honor of pleasure of being the PI for the CS for All Teachers community. We are a wonderful community of practice that is supported by the National Science Foundation for computer science teachers and those interested in computer science all across the country. Grant, if you could go ahead and forward to the next slide, please. Tonight, we're really excited to have two guests with us, Michael Stone and Grant Hufford, who will introduce themselves and introduce this concept of building interest in computer science through gaming. We have a small but mighty group tonight, so we do hope there to be a lot of interactivity and discussion about this wonderful topic. Grant, who is from CodeSpark, will be sharing a little bit about the things that they offer. And just as a quick disclaimer here, we're not necessarily, we haven't been paid for this. This is an official commercial. But Michael, who has done a lot of work with the elementary grades, has seen the real value of this program. And we were very appreciative of Grant, who was willing to come and talk a little bit about what they do as one option for the use of gaming. So we're glad to have them both here tonight to talk about that. We do encourage you, if you have connected via audio, that you mute your line. If you're on a phone, you can just mute your actual phone device. But if you're connected via computer, you should see an option in the drop-down menu at the top that will allow you to mute your line, and that'll just help on the background noise. So I'll be here to help answer any questions and keep an eye on the chat window. But with that said, I'll go ahead and turn things over to Michael to get us started. Thanks, guys.
Well, hello. Thank you guys for joining us this evening, and thank you, Melissa, for having us again. We're really excited to be a part of this one tonight. And quite frankly, the very first webinar I did with AIR and with the community of practice specifically, Grant Hufford was a participant, and he was in the webinar. We ended up connecting through the webinar and have continued to talk and just develop a professional relationship. And we are really excited at Devex about what they're doing at CodeSpark and specifically what they're doing with the FOOs over there. So I'm not going to talk too much about CodeSpark and the FOOs. I don't want to steal Grant's thunder. But Grant, if we could go on to the next slide here, and we'll actually skip on to the next one as well. So I'm sort of going to moderate the first part of this and talk to you a little bit about what we're doing at Devex. So Devex is a national professional development organization. We deliver PD all across the country. We started in project-based learning and continue to build a lot of professional development around project-based learning. But we really found an interesting opportunity with computer science, and specifically bringing computer science to K-8. And at the K-8 level, excuse me, we've had just a lot of interest. And also a lot of success here. We've only been going for about 18 months with this, and what we get asked all the time is from teachers. They'll say, we engaged in an hour of code. This is elementary teachers in particular. We engaged in an hour of code. We've worked through code.org's stuff. We love it, but we're ready for what's next. And so we're trying to help teachers figure out what's next. And as for those of you that were on the line a little early, as Grant and I were talking earlier, for us, the big key there is how do we make computer science become something that's a core value in the classroom. And in elementary school, that's a particular challenge because we know that students are still developing foundational skills. So if you go to the next slide, for us at Devex, when we talk about computer science at the elementary level, we separate it across a couple of kind of lines of demarcation. Specifically, we're particularly interested in developing students in early elementary school who are lacking proficiency in literacy, and then we pivot once they get proficient in literacy. We kind of shift platforms. We do a lot of work in Scratch with sort of later elementary, early middle school students. But for that early elementary piece in particular, and quite frankly, for the teachers at large, we really love what CodeSpark is doing with the FOOs. And I don't want to steal Grant's thunder, but just quickly, I wanted to say that I actually just ran a professional development session with about 50 elementary teachers 2 weeks ago in Southeast Tennessee, and trained them all on the FOOs. And they loved it for their classroom. But what I found particularly interesting, running professional development all over the country as essentially a full-time job, what we see out of teachers in computer science, especially at the elementary level, because they've not had any formal training in computer science, there are some barriers, and most of those barriers tend to be rooted in sort of self-perception. Elementary teachers have a tendency to perceive themselves as not identifying with computer science, that we hear all the time. I can't code, right? Computer science just isn't my thing. And what we found really fascinating is that using the FOOs, we actually make early elementary teachers, one of the first things we do, we plug them in on the FOOs. We tell them, you're going to wear the student hat. We ask them to jump in and use it. And as they do, we found it really develops a strong foundational understanding of what computer science is, and particularly what coding is, for the teachers. And so that success has certainly been powerful and just been kind of informing for us. But it's also transferred nicely into sort of where we're headed. So Grant, if you could go to the next slide. We have a little bit of data from that. This is limited. It's not. We don't have a large enough sample size to report anything, that's ridiculously in terms of moving the needle. But we are seeing participants reporting an average increase, nearly 73%, in their confidence in their ability to integrate computer science. And so that word integrate is really important for us. When we look at elementary school, because elementary teachers are teaching those foundational skills and in math and in terms of numeracy and literacy and science, we don't want to put something else on their plate. We don't want to just shove one more activity on their plate. And far too often that's what we hear, that the time is valuable, that while elementary teachers may find computer science interesting and can see conceptually some value for their students, it's not a tested subject. And frankly, as a dad of a second grader, I'm not sure I want my daughter's teacher teaching computer science in place of reading. She has to learn how to read, and that is a critical piece. What we've started looking at, though, is can you use computer science as an instructional tool to help essentially shift, and Grant, if we could switch slides here, essentially switch those core subject kind of core skills to help move them from abstract theory to functional concepts. And what we know is for that to happen, we have to move just from sort of the foundational knowledge that's critical to literacy and to math, especially at an elementary level. We have to find a way to put students in an authentic experience, to let them engage in authentic problem solving. And it's rhetoric we talk about a lot in school in general, certainly in elementary school. But what we find is that because those students are learning and still developing in like the K2 space, that they're still developing those foundational skills, it's very difficult to have students engage in truly authentic problem solving. Where we find a nugget of hope is with computer science and apps. There's certainly a number of apps out there and platforms out there, things like Tinker, Scratch Junior, a number of them that you could use with students that are engaging, certainly code.org. But what we love about the FOOs in particular, and so this is sort of an unsolicited commercial for them, I suppose, for me personally. What I personally love about the FOOs is that working with my own daughters and then also working with teachers in early elementary school, what we see is a nice blend of open-ended coding where students can really go in and create whatever they want to create. But the guys at CodeSpark, and Grant, I'm sure is going to speak to this in a moment, they've gamified it in a way that students they just develop intrinsic motivation. But speaking back to that authentic experience piece, because early elementary students are digital natives, because they are accustomed to playing games, creating things in the digital world is an authentic experience for them. And this becomes one of the first opportunities for students in their academic career to truly engage in authentic problem solving, if we can equip them with the tools to engage, to use computer science at a functional level. So we're really excited about what we're seeing with this. We've trained about 150 teachers to use the FOOs, and specifically to use the FOOs as a platform to integrate computer science in their classroom at the K2 level. And we really love what it's doing to help students both engage in those authentic experiences in a gamified way, where they're solving puzzles to develop the basic skills, but then after they solve those puzzles, to really jump into some creation and have be able to move up Bloom's taxonomy, essentially. So Grant, if you can go to the next slide. I'm just going to skim over this real quick to basically say, why is computer science important? I think I just answered it. For us, it's about, at the elementary level, it really is about providing students with perhaps their very first opportunity to really engage in truly authentic problem solving, where we're not having to trivialize or sort of dumb down the types of problems they're engaged in, but they can actually create real games. They can create real functional apps, and that function brings a level of authenticity that is very hard to replicate at the elementary level. So with that said, I'm going to turn it over to Grant Hosford, CEO of the of CodeSpark and one of the creators of the FOOs, and I'll just let you take it away.
Hey, thanks. That's an amazing introduction. I feel like a lot of my work has been done for me. And, Michael and his team are really our key partner for professional development. And we've handed off several projects to them, and they always do a fantastic job. So that we've given them work in multiple states now. And every time we get a report back, it's nothing but, A plus for him and the team. And I just wanted to thank CS for All and Melissa for organizing this and for everybody who's joining. And a couple just technical points. Because of the way the webinar is set up, I cannot see the chat while I'm in presentation mode. So, but please do submit questions along the way, and Melissa will be monitoring that for me, and we'll jump in. I want this to be as useful for people as possible, and am happy to kind of step away from the slides and answer specific questions. Um, so I'm going to jump in. Just a little bit about us. CodeSpark was founded 3 years ago, and the origin of the company is that my middle daughter Naomi, when she was 6 in first grade, wanted to learn how computers work, and she took a Lego robotics class that she signed herself up for, and she loved it and invited me to come check it out. And when I did, uh, I had three big surprises. So surprise number one, out of 24 kids, she was the only girl. Surprise number two, she was the youngest kid in the class by 4 years. So the next youngest was 10. And then really the shocking thing to me was I went looking for an ABCs of computer science. It just made sense to me that that would be a thing in a world where software touches so much of our everyday life. But it wasn't a thing. And so I started to get obsessed with the idea of teaching young kids to code and giving them, their entire school career to master this new literacy that is computer science and programming. So that's how the company was born. And because of that emphasis on trying to help my daughter, um, you'll notice that there's touches in the foods that are specifically girl friendly. We have powerful girl characters. The very first character you see is a girl. We pay a lot of attention to gameplay to make sure that both boys and girls enjoy it. And so I believe we're the only coding app that has a user base that's 50% boys and 50% girls. These are some fun shots from around the world. CodeSpark has been used in 224 countries at this point by over 5 million kids, and that's in about the last 26 months. These are some fun make your own food submissions from a contest we ran a few months ago. Um, it might surprise you to know that kids are building more projects on CodeSpark Academy with the FOOs than they are on Scratch. Um, on Scratch, kids build about, and this is public data, they build about 22,000 projects a day. And on CodeSpark Academy, they build about 27,000 projects a day. So we have a super engaged community globally. It's about 65% US. So a little bit about our impact. So far, we've been used in over 20,000 schools by, like I mentioned, 5 million kids. And our goal for 2020 is to be in 100,000 schools and 50 million kids. And one thing that's really important for me to mention from the beginning is that CodeSpark Academy will always be free for teachers. It's free today, and it always will be. Our business model is that there's a subscription service that we make available to parents. But for schools and libraries, the product's completely free. And so I'm going to jump in. I want to show you, I find that I can either talk about the game for half an hour or show you a little bit about the game. for 3 minutes, and it tends to make the conversation a lot more meaningful once you see uh, how and why we're doing some of the things that we do. Um, the way the game works, we start kids in self-directed puzzles, and hopefully my screen won't go too crazy here. I guess you get to see, there we go, shots of my family. How's that look, Melissa? What are you seeing right now?
We've got your PowerPoint right now. Let's see.
Oh, I lost my,
That's the PowerPoint we had the game.
yeah, I don't know what happened. Sorry, one, of course it was briefly there. Okay. Um, Hopefully this will take 10 seconds, and if it doesn't, we'll abandon it and go with the with the slides. Come on.
There we go. It looks like it's coming up now. There you
Yay.
go.
Yeah.
Okay, thanks. So I'm going to keep it in this mode just so everyone can see things. But so the goal that we have is we believe pretty strongly in the idea of transference. Um, you're looking at a profile that I've been playing for a while, so that's why there's things filled in. But what I mean by transference is we teach a concept in one area and then we let um, kids use that concept in a number of areas throughout the game. Another thing I should mention, and this is important for the K through 2 teachers in particular, is that there's no words in the app other than some titles of chapters and things like that. All of the navigation is word free. Um, and so when you first come into the game, the very first thing you do is play these puzzles, Donut Detective, and you'll see the character is a girl. This is Gracie, little nod to Grace Hopper. Um, and Gracie's lost her donuts and has to get them back. We do literally hundreds of hours of kids testing every year as we're developing these puzzles. And so I'm going to point out a handful of just small details that I think teachers will appreciate. Um, One, the scaffolding in terms of how quickly it gets difficult is really careful and basically the difficulty increases very slowly, but the puzzles are bite-sized. So, kids who are 5 years old can make their way through them. It's a, basically self-directed experience. And kids who are older, 8 or 9, just play faster. So in this particular puzzle, we're teaching kids that they can use more than one command at a time. Um, we give lots of positive feedback. We don't really give negative feedback. If you don't solve the puzzle, it's just kind of looking at you saying, hey, are you going to finish this? But we're explicitly promoting the idea of test and learn. And then we only introduce one concept at a time. So for example, we just introduced this new jump character on the bottom of the screen so that now you can make her jump. You'll notice there's a high color contrast between the walk command and the jump command. That's a direct result of testing with kids who are colorblind. About 10% of all boys are colorblind, about 1% of girls. If both of these little characters are purple, they don't notice the difference as much between them. Um, so you can see here, this is what happens if we don't solve the puzzle. She's just waiting for you to give her more instructions to keep going. I can restart or I can just try something else. And then here, we actually had an extra command for what we really needed to finish, but we still get 2 stars because we finished the puzzle. So we don't believe in any brick walls in terms of progress. We reward efficiency. So the way to get 3 stars is to think the solution through from beginning to end in your first try. But if it, takes you 2 or 3 tries, that's fine. And then we get a little stricter over time in terms of, what we consider to be a quote efficient program, but there's always more than one answer. So that's another really, sorry, my daughter's reminder is popping up for me. That's one really important thing about what we do, which is in computer science, there's never just one right answer. And so that's the same thing with our puzzles. After the very first puzzle, all of our puzzles have more than one right answer. And we do have a teacher's guide and we have an answer key and so forth. But, the point is that there's various ways to make these things work. So you get the idea. I'm going to just show you two more things quickly before we jump in back into the program. We have multiple characters, right? So the next character is our builder. This is where we introduce the idea of a loop. Go back one. And so I like to show this one because it's important for two things. One, it's the first time we introduce the loop, and it makes the loop feel powerful because normally he has a animation where he kicks his hat off, makes a crate, and then puts his hat back on. But with the loop, he just cranks the crates out. And the kids feel that that's faster right away. And then they know they need to get that tool up top. And so, they drag this jump command in here. And if I'm 5 or 6, I might be thinking that because that's the last thing I touched, that he's going to jump now. But of course, he builds 3 more crates first because that's what I told him to do. And then he jumps. And so when I'm in a first grade class watching kids play, you hear a lot of like, oh, I get it, right as they're going through this puzzle. Okay. Then there's multiple parts of the app, including some mini games that reinforce computer science concepts. But the thing that really sets us apart is our game maker. And the game maker starts with these 9 tutorial levels that show you how to play. I'm going to skip those just in interest of time, but the game maker allows kids, as young as kindergarten, to make and play their own video games. And then they can share those video games with their peers. So when they're in create mode, they can scale objects up and down. They can rotate those objects. They can delete them. They can copy them. But the most important thing is they can program them. So if you look at this little bad guy here, I've programmed him to make a rainbow and then jump around in an infinite loop. So we can push play and see that that's kind of cool. He's making his rainbow and jumping. And then I can play this just like I would a Mario game, right? And you can see that some of it's unfinished. This particular game has a blueprint to help kids make it. We do a lot of hand holding the first time they go through the game maker. But when they're ready, they can pause and they can either publish it or they can save it for later. The games, when they're published, end up in this community. And this is the last thing I'm going to show you. And in the community, kids can play each other's games. So every game has a unique code. You can see it down on the bottom there. So if I want to share this with my neighbor, with my teacher, with my mom, then I can. And you can see this game has been played 1,654 times. It's been liked 263 times. And then importantly, it's been remixed 224 times. And so we find that the kids do a lot of learning from each other, because if you remix somebody's game, you can go in and touch on anything in their game and see how it's been coded. So I don't know if any questions came in about the game, but if not, I'm going to jump back into the deck.
I haven't seen any questions in the chat room.
Okay, great. So thanks for putting up with that. I'm going to go through this next part kind of quickly, but we've built a teacher dashboard to let teachers track individual student progress if they want. Now, just to be clear, if you want to use CodeSpark Academy casually, you can just set up one profile and not worry about tracking progress. But if you'd like to, track progress individually, it's very easy to do. You just put in a name, or you can import through a CSV file, or just whatever the easiest way to get the class data in for you is. And then you can track their progress as they go through the various puzzles. And the puzzles are very strictly tied to our curriculum. And our curriculum is based on a combination of a curriculum called Exploring Computer Science out of UCLA and the CSTA curriculum. So very much based on standards. Different kids will progress through at different times. Very importantly, there's a few things that you have control over. One is you get some daily activities that you can take the kids through. Oh, let me see some. Did we change the deck because we had problems with it? Oh, yeah, we did. Okay, let me just talk about this for a second before I jump ahead. Um, Another thing about the teacher dashboard is that you can click to see what standards relate to these different concepts. So for example, if you click on the sequencing concepts, it will show you alignment with Common Core, Next Generation Science Standards, etc. So it gives you some, and in that way, if you know you're trying to teach logical thinking based on Next Generation Science Standards, for example, you can kind of back into what you could do in the foods that would, relate to that. The other thing is that you can control what areas of the app kids have access to. So, you've got a class of squirrely first graders. You want everybody doing the same thing at the same time. You lock down all of the different parts of the app except for loops. And that way Naomi isn't off making her own game and Samantha isn't over here, jumping ahead into conditional statements or something else. In terms of the other content,
Uh,
I'll go through this and then, yeah, go ahead,
Grant,
Michael.
I'm sorry, I was muted. We had a question from the chat room. Could you, Jill says, are the units that integrate into math, are the units that integrate into math or science curriculum? And you were talking a little bit about that, about the standards alignment. And she asked if you could please show that again.
Oh, yeah, you know what? What I'll do is, well, let me see if I can do it on the fly. Hold on. I'm going to try to log in and show you what that looks like while we're talking. So here we go. So, and then we have um, a set of lessons that come for free with the game. There's 10 lessons. A couple thing about it is that, sorry, I guess I can't type and talk at the same time. Okay, so here's the teacher dashboard, and we're gonna try to sign in. Hopefully my hold on. I have so many logins, I forget which one is that. Well, I'm not gonna make you guys go through sign in. Anyway, so once you set up your account, um, there's links to this 150-page lesson plan, and you don't have to print all that out. It's just in PDF form. But all of our lessons, not only do they include something, of course, related to the game, but they include a printable activity and they include an unplugged activity. So, if you've got the power out like Michael does, or you just don't want to go to the computer lab today, but you do want to do something fun with computer science, there are unplugged activities to take advantage of. And then if you make it through all of those activities, we actually have a separate free curriculum around game design for this same age group that we tested over the course of last summer. We run free camps for girls, low-income girls of color here in Pasadena. And so we did several camps last summer and developed a game design curriculum around those camps, and it was a big hit. The girls loved it. And so we have worksheets related to that as well. Does that answer all the questions? Anyway, here's I'll put this for people who want to just go poke around and check out the dashboard. I'm putting it in the chat. Like I say, free to use and super simple. Okay, back into presentation. So I'm going to run through this content really quickly, and then we can just do some Q&A, I think, which, I'd love to hear what people are interested about. I'm happy to talk about, anything from, getting girls into STEM to why game design, and what we like about game design, um, and other elements about getting started with computer science. So we have daily activities in the app. This, it doesn't eliminate the need for the teacher to use the lesson plan, but certainly if you want to use the app as like, hey, it's free time, you guys want to go, do you want to go play CodeSpark Academy? Great. Everyone who opens that app will have their own, set of activities for that day, depending on how far they've gone in the app. So it's personalized to each student. We talked about the puzzle, so I'll go through this quickly. This is where we introduce concepts and characters, and we just have this thoughtful progression from one concept to the next. The other thing is we have this, helping hand that, instead of having words, help kids focus and, solve certain difficult parts of the process. And what we found, it's really interesting. Kids pay much more attention to the hand than they do to words. 5, 6, 7-year-old kids, they don't want to read. They just want to play, and they're kind of touching everything and trying to figure out. But if there's this hand pointing them in the right direction, they will pay attention to it. We do have short videos in the app. I didn't show that, but we have these 3 to 5 minute videos that teach very specific concepts. So, for example, the image up on the top right of the alligator is a short video about using loops. And we use loops in this particular case to make those teeth disappear and then reappear. And so you set up this fun timing thing in your game where if you want to get to the star and end the game, you've got to time your jump into the mouth for when the teeth are in the disappear mode. And then the game down below, we actually can teach the kids how to make a little soccer game where they control one of the characters and the other characters just react automatically. Our blueprints are another way that we solve the blank page problem. Even though, we think it's super important for kids starting in kindergarten to be makers and to design and build things themselves, we know that it's not realistic for them to just look at a blank game and build something from scratch. There's a lot of steps to getting to the point where you can do that. And so one of the ways we get around that is we have dozens of blueprints that teach the kids how to make different kinds of games. And in the beginning, we hold the kids' hands quite a bit all the way through the process. And then by the end, we typically introduce them to, maybe 30% of how to do the game, and we let them figure out the rest. But blueprints are a combination of, short videos showing the kids what the game is going to be, then carefully scaffolded interactive exercises where we show them both how to build what's in the level and how to code it. And, these have proven to be really popular. Kids play them over and over again, and we see these games get more sophisticated each time they play. The game maker we talked about, I think the only thing I'll mention here is just the kids are really proud of what they make. We also have a lot of fun teaching the kids to give and receive meaningful feedback when they share their game with their friends. And we found that that's a really powerful conversation for kids this age, and it takes a little coaching, but you get really cool conversations when you do it, and so we actually encourage play testing. And then something that's coming this fall, one of the things I'm excited about is we've got a whole new block of content that'll roll out in time for the new school year around variables. As far as I know, we're going to be the only coding app teaching variables to young kids. And we do it in a way that starts out very concrete with collecting gems, which is a game mechanic that all these kids know. And then we eventually lead to more abstract concepts where the variable can be, among a bunch of different things that they pick. So it's been testing well, and we're excited about it. We also have a really cool big new module coming out either end of May or early June, where there's going to be a bunch of programmable pets. And I can't say a ton about it. It's kind of our secret project right now, but I can pretty much guarantee you that your kids are going to dig it. So, lots of fun feedback from around the world about what we're up to, and we're really proud of that. But, what's important to us is to introduce as many kids as we can to computer science, build their confidence in it. And that's why we focus so much on helping them have fun, is that what we've seen is that as much as the knowledge the kids get, it's the confidence that technology is something that they can have an impact on and use as a tool, and then the interest in it. So by walking before they run, and really playing with these concepts in a variety of ways, they end up with quite a bit more interest in the subject. And I've got efficacy studies on the product that I can share. Happy to send those out later to anybody who's interested. Um, so that's the deck, but I'm really happy to dive into some of the other topics that I mentioned. Why game design? How do you get more girls involved, etc. So I'm gonna go out of full screen mode so I can see questions come in, and just shoot your questions to me.
So feel free to put your questions in the chat window, or we'd love to hear from you as well.
Oh yeah, true. If you can just unmute and ask a question, that's great.
Melissa, there is PD I know listed on the CS for All Teachers website. Could you offer some insights there for Jill?
Sure thing. Jill, I will put the link in the window in just a second here, but we list the webinars and other activities we offer on the events page on the site. And so typically there's about, I'd say, 2 to 3 webinars each month that takes place. So I'll make sure to post that link, and then I just encourage you to save it under your favorites, and then you can visit that often.
And then
I'll also mention that we update, so if there's a preview, you can go back in time on the calendar to a past month, and we update those listings. So if you missed a session, we will put the webinar recordings and the related materials, so that's something that you could be able to access there. Is a question about the matrix to me, Jill? I just wanted to clarify
yeah,
that.
I remember, Melissa, at one point there was like, and Jill, I may have misspoke previously. What I was getting at was for high school teachers, particularly like if they're specifically looking at like APCSP or Emmanuel Shanzer's work with Bootstrap or
Got it.
ECS, right? So some of the course specific PD.
Okay. Sure, sure. So we, the way that the site is organized is based on, or it's been reorganized, I should say, from what we've had in the past. So since, I guess, mid-September, we've grouped things by what level that someone's working at. So when you log into the site on the main page, you'll notice that there is I'm going to give you the main homepage link. There's a drop-down button that says elementary, middle, and then we have it divided high school CSP and high school ECS, and then all groups. So there is where you list, and those for the elementary and the middle school levels, we just have like one open group. It's something that's more nascent in our development. With the high school CSP and ECS, we list all of the projects that NSF has funded under their CS 10K initiative, which was part of our former name, the CS 10K community. And so that lists a number of the projects that support PD throughout the country. So hopefully that is helpful to you, Jill.
I think we saw a question from Zena. Your hand was up. I apologize if I'm saying that wrong. Yeah, we cannot hear you.
You're welcome to add your question in the chat window there so we can address it.
Grant, I believe I know the answer here, but I'll let you answer this. Jill is asking, will the cost model always be free for educators? Is that long term?
And Greg, you may need to unmute your line.
Yes, I do. Thank you. Yes, it will always be free for educators. That will never change. And we actually, when we went and sought investment for CodeSpark when we were founding it, we went and found investors who were friendly to that idea. So if you know the folks at Caper Capital, they're highly interested in closing gaps in the study of computer science for girls and kids of color. And so, everyone in the company is aligned around keeping it free for public schools and for libraries.
Awesome. Awesome. And I think we've got someone calling in a moment to chat. I wanted to add to what Grant was saying previously in the presentation that some of the things when he was showcasing the alligator with the teeth coming in and out, that just when I was talking at the beginning, that level of authenticity for the students when you play those games, they play exactly like a side-scrolling video game that you play in an app on your phone or on a Nintendo Classic or whatever. And the kids are just they're super familiar with it, and frankly, the adults are super familiar with the aesthetics of the platform, and it really makes kids feel like not. I mean, it's not deceiving them. It makes them feel like they're playing or they're creating a real game because they are. And I think that's one of the most powerful pieces here is that it's not just a puzzle solver where you're developing skills to solve the next puzzle, but that you're blending that. And you talked about transference. I think that's so important that you're developing skills and then able to immediately transfer them. And I think one of the genius pieces is that, excuse me, I think one of the genius pieces there is looking at how you incentivize the kids with the stars as the currency. So they're incentivized to become efficient programmers so that their games can be better, right? They buy things in the shop with stars. So you're not looking to get them to spend money, but they actually get to use those stars that they acquire for more efficient coding, which is just awesome. Jill, I'll jump to your question in a minute. I think we have somebody on the phone with a question.
Hi, can you hear me
Yes,
now?
there we go.
Oh, good. So by the time I type these all in, it'll just be crazy. So thank you so much for having this. I am a high school teacher, so, this is a little young for my kids. But what I'm finding is that there's like a huge, I'm sorry, one second. There's like a huge disconnect from high school to elementary. So the eighth graders or the ninth graders that are starting now, they have like no experience at all. And so sometimes this can actually help them.
Yeah,
So is there, you know what I
yeah,
mean?
so we did a bunch of testing with middle schools in Las Vegas as part of a Verizon grant that we won. And to be honest, I was nervous about it because we focus most of our energy on, making the game work for elementary school. What was really interesting is that in this case, all of the kids had never been exposed to computer science before. And sure, they played the puzzles pretty quickly, but it honestly worked quite well for them. And then when they got to the game maker, they went crazy, because they were more sophisticated thinkers. They just made amazing stuff and they really got into it. And I think what was most important about it is that because it's such a friendly environment, it demystified computer science in a way that was really exciting. And then, we circled back to the teachers that we worked with about 4 months later, and they said these students, their willingness to try something that was more difficult and more text-based had shot through the roof, because they got a taste of what it was like to be able to create something cool.
Yeah, absolutely. And, so I'm actually working with seniors, and this is the first year that we're offering computer science in my school. So we started with Scratch, and I had actually started with the ECS curriculum. However, I guess it's more understanding the principles behind computer science.
Yeah.
And to get the kids interested, I went right into the Scratch programming. And they liked it. They really did. But something like this, they would like even better. So I guess my question is that are there any plans to make it a little bit more advanced? Because I think the platform is amazing. And I think, next year we're going to start a 9th grade class. And I just think it would be great. I think it's so interesting, especially that whole pet thing. Like 9th graders love that stuff.
Yeah. So,
Stickers and,
no, I
like
really,
they just love all of that.
yeah, and I really appreciate the question. So, I guess what I would say in the very short run, like the next 12 months, what I can say for sure is that we are going to keep adding more advanced curriculum like variables. And we have plans for functions and, some other key concepts as well. So the level of sophistication that you'll be able to reach with our, visual approach will get pretty high. Um, Having said that, we're not trying to knock people out of the high school space, but we do think that we'll just increasingly be the best place for beginners and the best place for early makers, and even sophisticated. And then the other thing I'll say about high school is we've got some great anecdotal feedback that high school teachers are having their kids use CodeSpark Academy to teach younger kids. And what I love about that,
Okay,
so the younger kids get attention from the high school kids, which of course I think is awesome. And the high school kids have to
of
be
course.
teachers, and so they lock down these concepts in a way that they probably wouldn't if they were just playing on their own, you know? So that's one idea for you that might be
Right,
fun.
right. Okay, great. Well, it's a great program. I'm really happy to see it. It's, by the time we catch up, I guess, and we do kind of all kind of come together and make computer science more of a core class than one of those just extra classes.
Yeah,
Hopefully,
yeah, we agree. We think the future of
we can.
computer science is integrating it into, other existing subjects, especially in elementary school. Um, but it'll take probably a little while to get there, but we're already thinking about that. Really, computer science is a tool for solving problems in other places. So I think
Right.
over time that's where you'll see things go.
Okay, perfect. Thank you so much again. I really
Oh
appreciate
yeah,
it.
no, thanks for joining us.
And Mike,
Yes.
is that the other gentleman's name?
Hi
Hi.
there.
So you were also saying that you were on a PD committee
Yes. Yeah.
for
So
standards. So is this going to be like standards that are going to be accepted through K through 12 curriculum?
so it's not for standards. So the CSTA has already created, I guess, adopted CS standards for K-12. They're available through the CSTA.
Okay.
I'm on the CSTA PD committee, so it just started, I guess, 2 or 3 months ago now. And what we're specifically looking at, and we're trying to ramp up there's a CSPD, they call it Computer Science Professional Development Week in July, and in preparation for that, they're trying to come up with a formal. The committee is working to come up with a formal vetting process, because as computer science starts to explode throughout K through 12. There's just a number of groups starting up to offer professional development in the K-12 space, and the question becomes, excuse me, the question becomes, how do you know as a lay teacher, if you're not ultra familiar with the space, how do you know what is good PD from bad PD? and what are the benchmarks that we can use to vet that. So that matrix hasn't even been created internally yet, so certainly nothing ready to be published. But that's the goal of that committee. That's one of the primary goals, is to get that out.
Okay, because like in New York, we don't have a computer science certification for for high school
Sure.
teachers. Here, you need specific content certification, and in New York, we do not have one. And New York City has not really adapted any CS standards. The only thing they put into play is that within the next 10 years, every school has to offer it. So I'm always interested in the standards, because right now I'm trying to use like AP standards, and it gets a little crazy.
Sure. We actually work. We know Elena Aaron pretty well. They're in New York City Public Schools, and I mean, it's a real challenge, and just to give you some assurance, that's happening everywhere. I mean, that every state is in that boat to one degree or another. Some districts and states are pushing a little farther, a little faster, but it is certainly a big question mark, and in terms of qualifications for teachers, even a bigger question mark. Now, I will say,
Right.
sort
Okay.
of, so for our model, and this doesn't speak to you directly, but what we see through Devex with professional development in particular, and really just beyond professional development, but thinking about teacher training and thinking about how what teachers are ready, what does it mean to be ready to teach computer science at the elementary level. We believe that it's really less about developing robust expertise for the teachers, because the level of coding is not particularly advanced for students. The teachers require less, right? I mean, it just sort of makes sense. You don't have to be an expert at calculus to teach fifth grade math. You don't have to be an expert at computer science to teach fifth grade coding. But as it scales up, and what we see is the length of time and the amount of ongoing support that's required for high quality teacher training, especially when you're talking about moving in-service teachers. The NSF model for years now has been to fund programs that look at moving teachers from, like, taking a history teacher or an art teacher, teachers that are credentialed in other subjects, because they're just, I mean, in most states, there are, if they even have a credential for computer science, the number of teachers that hold that credential are small to none. And so as they look to kind of help teachers transfer from content areas over to computer science, the big question becomes, as the content gets more advanced, it's clear that you just have to have more training and more support.
Right. And New York, right, like this year, New York is definitely offering a lot of training and a lot of support. I wonder if those trainings are going to go towards certification in the future, or if, when they do decide to put a certification out, if, teachers that are currently teaching it are going to have to stop teaching it and to, get any credits additional that they need.
That's a great question. We talk with the folks at CSNYC quite a bit, and at similar organizations across the country, and that's on the forefront of everyone's mind. But so I mean, I think anecdotally the answer is no. They're not going to take all these teachers that have had formal training, that are teaching it, that are effective, and and suddenly say, oh, you're not qualified to teach it. But that being said, there does have to be some work done. There's some work to be done and some thought to be put into how do you credential those teachers.
Right. Okay, great. Thanks. Sorry,
No,
I just have so many questions.
no, we love it. This is a much better time. If we knew there were questions earlier, we would have stopped talking and just answer questions. as best we can.
Yeah, so I guess thank you again. It really was helpful. I think next year I will probably introduce this for like the first week or two to get the ninth graders started before I even look at Scratch. Because it's cuter characters, and even though they're 13 years old, they're still into the cutesy stuff.
Sure.
So I love it.
So I'll speak real quickly to that, and then we have a question in the chat window. So yeah, I think that's a great idea. Just personally, having taught high school computer science, I was an AP computer science CSA teacher, and I was in a school district. I was the only AP CSA teacher in a district with 45,000 kids, so nothing like New York City, but still not a tiny district. And excuse me. And having done that, I think absolutely, even with juniors or seniors, they're familiar, right? They, especially with Nintendo releasing the classic at Christmas time, and kids, jumping back into Mario Brothers and Super Mario Run and everything that happened there. I think high school kids, because of the nature of the games that you can create in the FOOs, I think they would be all over this. I think there's no good reason not
Yeah,
to do
absolutely.
that. We got to wrap up. We're right up against the closing window. Grant, if you don't mind to push to the next slide or two. Jill, real quickly, so the company that developed CodeSpark and how it relates to Devex and PEF. So PEF is, I work with PEF in Southeast Tennessee. I run a STEM hub locally for high school, for K12 teachers in the Southeast region of Tennessee. And then I also co-founded Devex. So they're two separate, Devex and PEF are two separate companies. I split my time between the two of them. There's a lot of overlap in the type of work. They're both focused in teacher development and sort of innovative learning opportunities for teachers. Um, CodeSpark developed entirely separately. Grant, you want to give like a 30-second where CodeSpark came from?
Yeah, if you missed it, it's just basically 3 years ago, well, actually starting 4 years ago, I was inspired by my young daughters to look into an ABCs of computer science because they really wanted to know how computers work. And when I couldn't find anything, I ended up getting obsessed with the topic and founding the company with a co-founder who's a rock star game developer in March of 2014.
Awesome. Well, and thank you, Michael and Grant, for this wonderful presentation. As I mentioned earlier, it may be a small group, but it sure has been mighty and certainly helpful. We did record the session, as we always do, so we can share this with others who were unable to join us. We are so happy with the CS for All Teachers community that we can bring in great folks like this who are able to share their knowledge and skills and wisdom with the community members, as well as those of you who may get connected with us via social media. If you're not a member of the CS for All Teachers, we do encourage you to join up. It is free to join the community, and so we welcome you to be part of that. We do have 2 upcoming activities. Actually, there's 3. There's another one that will soon be on the calendar, but for right now, on April 18th, we've got a webinar. We just moved from the screen, so I'm trying to remember what that one's about. I know the one on the 26th is focusing, thank you. On April 18th, NC WIT, which is the National Coalition for Women in Technology, will be sharing their programs and resources. It's a fabulous opportunity to hear from them. And then on April the 26th, we'll have one, Gail Chapman, who is one of the founders of ECS. We'll be talking generally about reflecting on the year and kind of taking away key lessons learned and how to apply that as you plan and think ahead to next year. It seems crazy to already be in that mode, but it's not that far away. So again, we thank you for being part of this with us tonight. Thank you very much to Michael and Grant for their wonderful presentation, and for all of you who joined us and your great questions. It was a great discussion. So I do thank you and look forward to seeing you again online soon. Take care, everyone.